Hello everyone, I hope you are fine. In this video I'm going to show you how you can specify and estimate a two-factor CFA model using the graphical method in EQS. So this is my two-factor CFA model. The first factor is interpersonal conflict with 4 items and the second factor is role conflict with 3 items. You can see the scaling item here and the factor loading for this item has been fixed to 1. Also we have another scaling item here and the factor loading has been fixed to 1. So these red arrows indicate that all of these passes have been constrained to 1. Alright, now let's go to EQS to specify this model. Alright, first let me open my data file. My data have been saved in a SAV file. So I just open this SAV file. This is the data file for SPSS in fact. So I just open it in EQS and now you could see that the extension of the file is changed to ESS. So ESS is basically the data file in EQS. Alright, now let me just click on this button which is new model helper, and then there are a few options here. In this video I'm going to use the model builder. So I just click on factor model and now here I have to define my factors. Here you can see the list of the variables in my data set. The first factor in my model will be interpersonal conflict, so I just locate the items for interpersonal conflict. Here they are, IC1 to IC4. I just select them, click on this button, and then it will be my factor 1. I just click on add, and then I have RC1, RC2 and RC3 as the items for the second factor. I click on this button and then I click on add. Alright, now here you can define which factor is the predictor and which one is the outcome. In our case we have a two-factor CFA model, so there is no outcome here, so I just skip this step, and now here I just allow the two factors to covary. So I just click on OK, and now you can see that the model is built, and what I need to do is to save the model first. I just save it as model 1. Alright, then I go to build EQS. I select title specifications. Here there are a lot of options. If for example if you are doing a multi-group analysis, the option is here. If you are doing a multi-level analysis, you can select this option. In case that we happen to have multivariate outliers, we can simply select this option to exclude them from our analysis. If you want to handle missing values, you can select this option, and you can see a list of normal theory estimators here. The default is maximum likelihood. I just accept the default. I also select robust methods because I have no idea whether my data are multivariate normal or non-normal. So I just select this because I would like to get the robust statistics as well, including Satora-Bentler chi-square and also the robust fit indices as well as the robust standard errors of the parameter estimates. So I just click OK, and then this is my EQX file. I just save it as model 1. And what I need to do is to run this model, and then you will see the output on the screen. Alright, done. So this is the output of EQS. But before we explore the output, let me just go to Window and then I select this EDS file. So this is my model. If I just go to view and then estimates and then parameter estimates, you can see the unstandardized values here, and in case that you would like to see the standardized estimates, you can simply select a standardized solution, and now you can see the standardized factor loadings and the correlation between the two factors. Now let's go to our output. Okay, let me scroll down a little bit. Alright, So here you can see the univariate statistics of the variables in our model. So all of the means, skewness, and kurtosis statistics, as well as the standard deviations, are displayed here. Then we have multivariate kurtosis. And note that the normalized estimate of multivariate kurtosis can be used to determine if our data are multivariate, normal, or non-normal. When this value is above 5, it means that our data are multivariate, non-normal, and then we have to consider the robust statistics when it comes to interpreting the results. So next we have cases with largest contribution to normalized multivariate kurtosis, and these are the case numbers for these 5 cases, and here you can see the estimates related to these cases. So when you compare these values, you could see that we really don't have any extreme multivariate outlier in our dataset. So we can proceed with the rest of the results report. Then we have the sample covariance matrix, and basically this is the covariance matrix that is needed by the software to estimate the model. And then we just scroll down a little bit again, and this sentence is very important, my friends. In fact, if you didn't see this statement in the output of EQS, you really have to check the output and see what the problem in your analysis is. So make sure that you see this statement in your output. Parameter estimates appear in order. No special problems were encountered during optimization. Alright, then we have residual covariance matrix as well as its standardized version. And let me just scroll down again. Here you can see the fit indices based on the traditional ML method. So because our data are multivariate non-normal, we really have to skip this section and we have to go to the robust fit indices section. So we just scroll down a little bit, and then here you can see the information that are in fact accurate and correct. Alright, so these are the fit indices based on the robust method. You can see the Satora-Bentler scale chi-square statistic, which is 225 with 13 degrees of freedom. Also, you can see the different fit indices here. The CFA is 0.956, which is an acceptable level. You can see that the RMSE is 0.09, which is a bit high. And then here you can see the iterative summary. It means that convergence occurred in 6 iterations in our analysis. And then here you can see the parameter estimates. Remember, since our data were multivariate non-normal, we have to resort to the robust standard error and Z statistics for any of the parameters that have been estimated. So you can see the first item for interpersonal conflict, it was the scaling item. So basically it has not been estimated, and it was fixed to 1, as you can see here. But the standardized version of this factor loading was 0.602. This is the second item for interpersonal conflict, or IC2, and you can see the factor loading here. This is the third one, IC3, and you can see the factor loading, the standardized factor loading here, and this is the standardized factor loading for the fourth item of interpersonal conflict. And then we have the 3 items for role conflict, RC1. Again, you can see that the factor loading was fixed to 1, so the this parameter was not estimated, but its standardized value is 0.67. Also, the second item is 0.916, and the third one, the factor loading for the third item of role conflict factor is 0.867. So here you can see the factor loadings and also the R squares for any of these variables, and also you can see that all of these factor loadings that have been estimated are statistically significant. You can also see the corrected standard errors here. So please don't forget that you have to report these statistics here because our data are multivariate and normal. Alright, then we have the variances section. Here you could see the variances for our 2 factors. So this is the first one, this is the second one, and you can see that both of them are statistically significant. Alright, then we have the error variances. Again, you can see that all of the error variances that are listed here are statistically significant. Then we have the covariance between the two factors. The covariance is 0.146 and its a standardized version, or the correlation between the two factors, is 0.487. And then again, you can see the standardized solution here. These are all the standardized factor loadings that I showed you earlier, and you can see the R-square values for any of these items as well, and the correlation between factor 1 and factor 2. So it was the results report for our two-factor CFA model. In the next video, I'm going to specify the same model, but this time I'm going to draw the model so that you can see how you can use different tools that are available in EQS to draw your model manually. Thank you very much for watching, and goodbye.